Okay, so we'll go ahead and get started. Yesterday was just maybe somewhat of a review day just to see what you may or may not have remembered from 2 years ago. So if we look at page 718, because we did some readings on page 711, okay, and we'll come back to some of these compounds that or structures that you might see on 714. 717 might look familiar, but when we look at page 718 on table 3, okay, we had listed all those compounds here, but we had just mixed them up between starting with methane and ethane. And then what's significant once you get beyond butane and start with pentane? They're geometrical shapes. Okay? So then one of the things that maybe you can realize or visualize between the two gases of propane to butane to then pentane. So if we start out with this, okay, now you don't need to write this down unless you feel so inclined that you want to write the molecular formulas as we get larger with these. Okay. So what type of substance, yes, these are all alkanes, but this also has a common name. Yes, we call it methane, but it's a method of heating your homes then too.
Propane.
Not propane.
Methane.
We we already called it methane.
Methanol? Furnace.
The common name.
Butane. Wood.
Oh.
Smoke.
Then once you hear the name, you're gonna say, God, I
Gas.
knew that. Well, it's close.
Gasoline.
Nope.
Would you heat your house with gasoline?
You can with diesel fuel. That's a way you can heat or run through your furnace.
So gas was close?
Mm-hmm.
Is it the same number of letters?
No. No.
Gassy.
No. No.
I run my house off of heat.
Yes, we call this methane, but it's got a common name, something gas.
Methane gas. Carbon, butane.
No. No. All things would just come naturally.
Natural gas.
Natural gas. Okay? So, since now gas it's a really vague term because some of you had mentioned this, okay? Well, maybe it is gasoline. Well, how can we say that this is gasoline and that this has gas in the terminology? I mean, it's just a socially acceptable aspect or social convention that, okay, you just call C8H18 gasoline. Yes?
Dumb question. Is hydrogen itself flammable?
Extremely.
What is that really cold stuff? Liquid, yeah, something like that.
Oh,
What, dry ice?
Liquid.
Dry ice, well, and then liquid nitrogen would be extremely cold too. Okay. Excuse me. Okay. So we call this natural gas, and then you say, I have to go put gas in my vehicle. Again, it's just a socially acceptable term, but if you're looking at it scientifically, what type of substance is this? Well, we already know that it's natural gas. It's one where if we were doing an activity in a lab, we open up the jet or the master valve, then you open up your valve with a Bunsen burner. You have propane going through there, and propane is a gas as well, which maybe still doesn't quite answer the question, why do we call this gas when it's not the same type of substance as this?
Because it releases.
Because what happens is this, you could say, is like an aerosol, just like if you have certain types of deodorants and sprays that you, and like Pam, that comes out as a liquid. It's a non-stick substance, but I suppose, I don't know if I suppose it's an aerosol that pushes it through there. But our point is, yes, this is in a gaseous state, but what happens with this if you are trying to light your propane grill? What type of substance is butane? Yeah, it's in lighter, so it's a liquid. So then what we see happening then is as you're going down, 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 you pass the gaseous phase, which is this one, this one. This one sometimes doesn't have its mind made up. This is a liquid. Pentane then would certainly be a liquid. Then hexane, heptane. And one of the aspects I think we, so yes?
Am I able to write like 1 through 10 down on a paper?
You should be able to remember that. So, no.
Yeah, it goes 1, 2, 3, 4, 5, 6.
Right.
Thanks, Preston.
Well, we already had said that you're worried about this, thinking, oh, what happens if I have to put some time into this? We already said what happens to this when you hit carbon 5.
Who says I know all the...
No, how do you
shapes.
name it?
The shapes.
The geometrical shapes. Okay.
I somehow got to get to 4. So,
Okay, I think if you have a problem getting to 4, you have bigger issues than that moving forward.
butane? I'm already wrong.
No, you're already wrong. Okay? So one of the things we had talked about with combustion reactions with the freshmen, okay, we had mentioned that, okay, we know that this is taking place in your car engine. It has to combine with oxygen, and we could write this out, CO2 and H2O. But within that gasoline tank that you fill up, whoops, didn't want that. You also put some of this inside of there. Okay, and you might think, okay, when we say gasoline, you're referring to octane. That's what this is. But then what is this?
Heptane.
Heptane. Okay? But what happens is when you pull up to any gas pump, okay, you see those stickers. Those stickers actually mean something. So visualize what you might see over here at Classic Corner. You pull up to the gas pump. What type of sticker might be on there? It's not the price.
97.
Okay? So, not 97. I don't even know if that's even possible around here. But, so, no, I'm not tripping.
91.
Okay? So, 87. Okay? So, what that means then is there's a mixture of 87% of that octane and 13% of that is heptane. Okay? So why might we do that? Well, for the same reason.
Because heptane burns hotter than...
Well, I think there's probably something to that, because we'll make sense of that in just a moment.
It's cheaper.
Okay? But for the same reason you would add these two together would be the same reason that you might put something like this inside of there. That is ethanol. Okay, so this is an extra additive that you put in your gasoline. So then, why is that heptane in there? Well, if we look at this scale here, I want to say something like C, and this is just a total guess. I believe it is either 10 or 11, 24. What type of fuel might that be? It's heavier than octane. Yeah, so if this is diesel, okay, because someone made the point, they said, well, this heptane burns hotter. Okay, well, okay, you have a set of brush, branches, and other things that you're going to do a controlled burn. Okay, so you want that to get started and you want it to burn efficiently or quickly. Okay, so what might you put on there to help start it?
Some fuel.
What type of fuel? Okay, well,
I'm more of a gasoline kind of a guy.
okay, so if you put this on as opposed to this, which is your diesel, what happens when that spark ignites your gasoline? It's really volatile. And it's not that diesel isn't volatile, it is, but it just doesn't burn as fast. So for the same reason, if this is fairly tame as opposed to this, well then just think of what happens when you have this as opposed to that. It just, like someone said, it burns a lot hotter. So that's some of the characteristics that you see with some of these hydrocarbons that we're looking at. But one of the things that we had said is, okay, we said this one really hasn't made its mind up yet because this is gas, so it's in an aerosol form. This is in an aerosol form. What about this one? No. You know it's this, but it's also this at the, it's not that it's at the same time. Okay? Because what happens is if you're going to haul this over the road, if it's in a gaseous form, it's going to take the entire container. It's going to fill up your entire container. But if you can have it as a liquid, it means you can haul more of this. But once you put it under pressure, this turns to a liquid. So then, or excuse me, once you relieve the pressure, it turns to a gas because if it's under pressure, it's in a liquid phase. You relieve that pressure, it turns into a gas. I think I said that right.
Right away? So like the moment you take that?
The moment you do that, yes, it turns to, no. No, it just, because I think there's certain types of regulators that you would have that allows only so much to go in, because when you hook your propane tank up, okay, then you have this, your connection, your hose maybe comes up like this, and then it's got this funny looking thing that has a dial on there. You can't turn this dial, but what that is a regulator that only will allow this to flow through at a certain rate, because otherwise, if I would believe if this propane tank is under pressure, it's going to shoot that through, and then you try to light it, you're going to have an explosion. So that's why you'd have a regulator on there. Okay.
Can you see it if it's gas?
You can't see it. The only thing you can do is smell it, and I think that's because there's an additive in it.
Thanks.
Right, and it should, because that's what it alerts people to know, okay, we've got some of this propane that's filling the room. So this kind of does both. This is in a liquid phase, and of course, the further down we go, those are all liquids then, which it has to be because we just don't harvest gasoline out of the ground. Just like you don't grab gold out of, you do, but with these, you don't get pure copper, you don't get pure silver.
You gotta refine it.
You have to refine it. Same thing with crude oil. So you have to boil that, and once you start to boil it in a fractionating tower, those lightest gases, they start to accumulate up at the top.
Oh, do we get to watch the video again this year or not?
Probably not. No. I don't think that's necessary, because you already seen that before.
I know, but I feel like now I pay attention way more than I did then.
So why is that?
Certain students aren't in the room to distract us.
Oh, so it's certain students' faults, huh?
Yeah,
Yep,
Oh.
we'll go with that.
Okay, well, I recommend you don't do that when you're out in society in the workforce. It's somebody else's fault. That's your answer?
Yeah, I guess so, yeah.
Okay. So, with that being said then, all right, as we look here, we told you to grab these books for a reason. So then you can see on table 3, you've got 1 through 10. It just has your prefixes on there. We already established that once you reach number 5, that's your geometrical shape. And then what do you notice about table number 4 on page 719? So what are you referring to when you're saying methyl and ethyl?
We do the.
They're acids, right? No. That's
They're not acids. No.
what page is this?
It is 719.
We do the cycloplanes eventually too, right?
Cycloalkanes?
Yeah.
Yeah, if you look over there on Thursday, it says ring structures, because that's what cyclo means, is ring. Okay, so we still haven't quite answered what's significant about that table 4 on page 719. You started reading it. What about yesterday? Yeah, it's the derivatives, okay? So I would find it really hard to believe that definitely, probably not the high school level that you do a pentyl derivative. We could do butyl derivatives, but that's more, let's say, appropriate for next year, because we talked about this yesterday, okay? That was the first derivative you learned, okay? Then you learned this, okay? So then, where do these come from? How do we name these, and where did they come from? What's page 719 telling you?
Based on the amount of carbons in it?
That has something to do with it, the number of carbons.
C2H5 is like the
Where
main
is this
chain.
on the chain?
So if this attaches, and we did it vertically, but if we do it in this manner, we say where X marks the spot, and your parent chain is here, okay? If this is a carbon to another hydrogen atom, well then we've got ethane. But if this is a carbon to carbon bond, okay, then it's no longer ethane, but rather what instead?
Ethane.
I can't
No.
tell. I don't.
Pentane.
No.
Butane?
Ethene.
C2H5 is what?
Ethane.
Pro.
No, that would be C2H6 if it's ethane.
Oh, shoot, it's a double
Ethyl?
bond.
No,
Methyl?
no, it's not methyl and it's not propyl. You got it surrounded.
Alkanol?
C2H5.
Ethanol?
C2H5.
Carbon 2 hydrogen.
It's odd.
Ethanol? Oh,
No.
I'm sorry.
Propyl.
Propyl would be 3.
Ethyl.
Ethyl group. It's an ethyl group.
Pentyl.
Maybe you did a long time ago. But we say if this is a methyl group, then this is an ethyl group. Well then what happens when you hit this one?
Propyl.
It's a propyl group. So then what happens is, as freshmen, you did these two. Then this year we throw a propyl group in there, and then there's one more, okay? What this means is, okay, this is a molecular formula. Sometimes it's better to use the structural formula. So let's go ahead and do how we started this yesterday. Okay. That's one too many. Okay, I'm going to put a big line there to separate that. Okay, so there's our C7H16. Okay, well, what do we remember from 2 years ago if we see something like this?
It's propane, propyl, something, I don't know. But you go 3 in from the closest side.
No. Yes, you do longest chain.
Longest chain.
Is that the answer to your question, or is
It's part of it.
It's oxo.
So what's your longest chain?
It still would be
Eight.
the.
1, 2, 3,
It'd
4,
still be
5,
your
6,
main
7.
one.
Oh, how it
Main
normally
chain.
is.
Okay.
Chain.
So your longest continuous chain we know is heptane. Okay. Is there anything branching off of that
Yeah.
heptane?
Methyl.
Yes, there is a methyl group. So what we would say is X marks the spot because that's where this is attaching. So we've named our parent chain. We say that there's something branching off of here. It has a formula of CH3 like what we have up here, and we know that it is a methyl group. Okay? So then we have to account for that. We would say, where is that methyl group located?
On the 4th carbon or the
Third.
1, 2?
Third carbon.
Yeah, 3rd carbon.
3
No,
methyl.
yeah, this is the closer part. You go from the closer side. That's what I was talking about.
Well, you could say closest side or what gives you the smaller combination. We'd say think about playing golf. Okay? That's your goal, is to have the smallest possible score. So then when you reverse engineer this, because at the senior level, some of these compounds that we put, do they exist? Well, maybe, but our practice is in how to efficiently name these compounds. So this is telling you something very specific.
There's no double bonds.
Okay, it's saturated, everything is single bonded, so it's an alkane. This is telling you something really specific,
There's 7 carbons.
that there's 7 carbons.
Longest parent chain.
This is telling you something,
There's
One on the bottom.
okay? That means there is somewhere on this parent chain, there's a methyl group, then that one just tells you where it's at, okay? So that's what they're trying to illustrate when they're talking about naming these compounds. They don't have, oh yeah, they do have a naming hierarchy. It's probably not quite as elaborate as the other book, but for senior level. But on page 721, let's apply some of these rules because sometimes it's easier to see an example then read about the rules as opposed to reading the rules and then going forward from there. So it says alkane nomenclature on page 721. Okay, it says name the parent hydrocarbon. Okay, that means longest continuous chain. Well, we did that. It says find the longest continuous chain of carbon atoms that have straight chain branches. Add the suffix "ane" to the prefix corresponding to the number of carbon atoms in the chain. So then this is saying just that. Add the suffix "ane" to the number of carbons that you have. That's what this is saying. This is single bonded, so it's an alkane. That's what number 1 is saying. Number 2 says add the names of the alkyl groups. And then an alkyl group is what you see on page 719. It has all, on table 4, all of those alkyl groups, 1 through 5. But we only do 1 through 3. We'll show you this in just a moment. Add the names of the alkyl groups in front of the name of the parent hydrocarbon in alphabetical order. When there is more than one branch of the same alkyl group present, attach the appropriate numerical prefix to the name. Di for 2, tri for 3. Tetra maybe comes up once or twice for the seniors, and then so on. Do so after the names have been put in alphabetical order. Then number 3, number the carbon atoms in the parent hydrocarbon. If one or more alkyl groups are present, number the carbon atoms in the continuous chain to give the lowest numbers possible. That's why we said think of golf when you do this. If there are 2 equivalent lowest positions with 2 different alkyl groups, give the lowest number to the alkyl group that comes first in the name. This will be the alkyl group that is the first in alphabetical order before any prefixes are attached. And that can happen with this as well. For instance, what this is saying, what about if we had a halogen derivative on here? Well, if we go this way, it's on the 3rd carbon. If we go this way, it's on the third carbon where it starts. But alphabetically speaking, okay, even though this is a trap, it says C, that's not the alphabetizing portion. It's this, okay? Here you can go by the C because it's chlorine. So since chlorine comes first, then it would be 3-chloral 5-methyl heptane. That happens occasionally, but it's just one of those things that you just need to find the lowest combination. And then if you have a tie, well, which one comes first alphabetically? All right. So we said we got these other derivatives that we need to name. And we'll go ahead and do that. Okay. In other words, let's say, for instance, I'm going to take this one off of here. And then, all right, well, let's put an ethyl group on here. Is that what we want to do, or is that a trap?
So you got octane.
Okay, name your longest continuous chain.
Octane. No, it's not.
Because notice we do 1, 2, 3, 4, 5, 6, 7. That has not changed. But we wanted to add this derivative on here. Okay, so that's where we think that it attaches to the parent chain.
That's still
But how many carbons do you have in your parent chain?
8.
It's actually 8. Okay? And in case we're wondering, it's 1, 2, 3. Okay? Then we know that there's 5 more after this. 4, 5, 6, 7, 8. So this branches in this direction. This is not an ethyl group. This would not be 2-ethyl heptane. Okay? It would rather be 3 what?
Hold on.
3 ethyl.
Not 3-ethyl.
3-methyl octane.
3-methyl octane. Because on our third carbon, we have this methyl group here. Okay? If we wanted an ethyl group on here, we'd have to go where we originally began and put it here. So now we have a heptane molecule. Okay?
So it's the same answer. Right?
No matter which way you go, you're going to get 3-ethyl heptane. Whether you go like this and say this is an ethyl group, or you go up and over, this would also be an ethyl group. Okay? Well, you could, and when we're talking about the di, the tri, the tetra, what that means is if we had another ethyl group, then you would have 3, 4 diethyl heptane. Okay? You have to include that prefix of di on there. Okay, so the last thing we want to do is, all right, now, is this a derivative, or is that part of the parent chain?
That's part of the parent.
That's part of the parent chain. Okay, so if we want a propyl derivative, we would have to take this one off and move it to here. Now you would have, what is that, 4-propyl heptane. Okay, 4-propyl heptane.
Yeah.
But there's actually 2 derivatives for this alkyl derivative. What we mean by that is we said sometimes you have to go by the molecular formula, which means when we say X marks the spot, what is the formula for a propyl group? Well, C3H7. Well, how many carbons do we have here?
3.
How many hydrogens do we have?
8.
7.
We have 7, because this is a carbon-to-carbon bond. What that means then is if we were to do this, again, X marks the spot. Okay? So now, it's not a propyl group. This is what we call isopropyl. Okay? Well, I think to me, the reason it's called isopropyl is because it's saying that it attaches in the middle. And what I mean by that is, okay, I think it'll maybe make a little more sense if we look at this. Okay, we know that that's an alcohol. That is propanol. Well, for anyone who gets a vaccination or a shot or something to that extent, they use isopropyl alcohol because this OH is attached in the middle instead of on the end. And since this is called isopropyl alcohol, I believe that's what makes these two terms connected. An isopropyl group and isopropyl alcohol.
How do you decide where to put it if there's not an exact middle? Just on one of them?
What, this here?
Yeah, like if there was four.
Yeah. Because on the top one we have 3 and then there's 4. So just pick one from them.
Okay. You're talking about this isopropyl group here,
Yeah.
okay? Well, we still have heptane, right? Okay, I did have to move it over one. There.
So if you were to say 5, comma, methyl butane or octane.
5, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. What are we talking
No,
about?
I'm just making one up.
Oh, okay.
Would you be wrong if you were to say?
Well, some of them can be isomers, okay? Because what this means then is we already know we've got 7 carbons there and then 3 more, so that means there's C10, okay? And then our hydrogens, we've got 3, 5, 7, 8, 10, 12, 15, 18, 19, 22. There's a whole bunch of isomers that you could make out of that, okay? And I think that's what you're getting to with your question. All right, I think that's long enough because I see we're up to about 32 minutes. So for those of you tuning in a little later, our main goal today was just talking about alkanes and reviewing what some of the derivatives were because we're adding 2 of them. In your freshman year, it was just these 2. Now you have a propyl group and an isopropyl group. And when you put these in alphabetical order, it gets to be a little tricky, but we will talk about that at a later time. I do believe there's no class tomorrow except for one of you. You are smarter balance testing at this time tomorrow. Is that correct?
Yes.
Okay. So then we will catch up to you next time.